geometric progression. In this progression, except the first term, all the remaining terms are obtained. All the remaining terms are obtained by multiplying their preceding terms, with a non-zero constant. Now, in this progression, except the first term, all the remaining terms are obtained by multiplying their preceding terms with a non-zero constant. Then the series obtained or the progression obtained is called the geometric progression. Now, general form of geometric progression. General form of GP is A, AR square, so on. A is called the first term, and R is called the common ratio. R is called the common ratio. So, common ratio is equal to second term by first term, which is equal to third term by second term, so on. Now, we wrote the progression, geometric progression definition, and then general form of geometric progression is given by AR square, so on up to A to the power n minus 1, and here A is called the first term and R is called the common ratio. Here, to get the common ratio, we should divide the second term with the first term or third term with the second term, so on. That is why this is called common ratio, because we are taking the ratio of two consecutive terms. The ratio of two consecutive terms is common. That is why this is called common ratio. So, general term of the geometric progression. General term of a geometric progression, Tn, which is given by A into R to the power of n minus 1, where A is called first term and R is called the common ratio. Then we go for sum to n terms of GP. Of a GP, Sn, which is given by A into 1 minus R power n divided by 1 minus R if R is less than 1, and this is equal to A into R to the power of n minus 1 by R minus 1 if R is greater than 1. This is sum to n terms of geometric progression. If mod R is less than 1, then A plus AR plus AR square plus so on up to infinity is called infinite geometric progression. So sum to infinite terms of GP. Which is equal to S infinity. This is given by A by 1 minus R. And this is true when mod R is less than 1. We can apply the formula for sum to infinite terms of a GP when mod R is less than 1. For example, if I take this 1 plus 1 by 2 plus 1 by 2 square plus so on up to infinity is given by 1 by 1 minus 1 by 2. And this is given by 2. And if I take like this 1 plus 2 square so on up to infinity is invalid since R is equal to 2, which is greater than 1. Is invalid since R is equal to 2, which is greater than 1. That is why this is not valid term, the valid sum. If A comma B comma C are in geometric progression, then second term by first term B by A is equal to C by B. That is B square is equal to AC. B square is equal to AC. Therefore, the value of B is equal to root of AC. Here B is called the geometric mean. Geometric mean of A and C. Now if I take the geometric mean, if G is the geometric mean of two positive numbers A and B, if G is the geometric mean of two positive numbers A and B, then according to the previous formula, we can write G is equal to under root AB. So the geometric mean of two positive real numbers is given by square root of A and B. If G1, G2, G3 are three geometric means between M and N, then M comma G1 comma G2 comma G3 comma N are in geometric progression. And one more condition we can write is G1 by M is equal to G2 by G1 is equal to G3 by G2 is equal to N by G3. So we can write this as G2 square is equal to G1 G3 is equal to Mn. This is also a condition when there are three geometric means between the numbers M and N. If G1 comma G2 comma G3 so on Gn are N geometric means between A and B, then we can say that A, G1, G2 so on Gn comma B are in geometric progression, and the common ratio of that particular geometric progression is given by R is equal to B by A whole to the power of 1 by N plus 1. This is the formula for finding the common ratio of the geometric mean. So R is given by B by A whole power 1 by N plus 1. If G1 comma G2 so on up to Gn are n geometric means between A and B, then kth GM, kth geometric mean is given by A into B by A whole to the power of K by n plus 1, and product of n geometric means is given by AB to the power of n by 2. If A to the power of n plus 1 plus B to the power of n plus 1 by A to the power of n plus B to the power of n is the geometric mean of A and B, then we can say that n is equal to minus 1 by 2. This is an important bit. If three numbers are in GP, then they can be taken as A by R, comma A, comma AR. If 5 numbers are in GP, then they can be taken as A by R square, comma A by R, comma A, comma AR, comma AR square. These are the 5 numbers that are in GP, and those are the 3 numbers which are in GP.